We're going to have a look at while loops in Java. And it says a while loop looks a bit like an if statement. We have the keyword while, we have an expression that is going to evaluate to a Boolean value. And if this evaluates to true, then the code inside will run. Like an if statement, the code inside a while loop will only run if the condition is true. However, a while loop will continue running the code over and over until the condition evaluates to false. So the code block will repeat until silliness is less than or equal to 10. Less than or equal to 10. It will run only until this one becomes less than, and it makes this whole expression evaluate to false, then is when it will stop. Meanwhile, if this whole expression evaluates to true, the code inside will keep on running. Now, if we have a look at this, and we have a variable that is set to 0, and it says while passcode, and this would be another variable defined somewhere else in the program, while passcode does not equal to this value, and attempts is smaller than 4, attempts being this one here, then execute these lines of code, okay? But what we can see here is that eventually on this line, we say attempts plus equal 1 means that we're changing the value, or we're incrementing the value of attempts, which eventually is going to get to be, is going to get this whole expression to evaluate to false. Therefore, it will break out of the while loop. Otherwise, you will be stuck in the while loop, and these would we not have, for example, this line of code, we would be stuck in an infinite loop. Because if we have the same code that runs without any of the variables being changed, then of course that code is going to keep on running and running and running, okay? While loops are extremely useful when you want to run some code until a specific change happens. However, if you are uncertain that change will occur, beware of infinite loops. Infinite loops occur when the condition will never evaluate to false. This can cause our entire program to crash. We have here an example, and we have a variable called hedgehogs, and it's set to 5. And it says while our variable is smaller than 6, then print this. Okay, and this is an example of an infinite loop, because this will keep on running, since this expression will never evaluate to anything other than true, okay? So we know that hedgehogs is 5, okay? It goes and it checks. So while 5 smaller than 6, this whole expression is going to evaluate to true, therefore run this code. And then it goes back again, and it says hedgehogs, what's the value of hedgehogs? It's 5. Is 5 smaller than 6? Yes, it is. Run. So it's going to keep on running this while loop infinitely, simply because nowhere in this code we're changing or we're altering the value that we're holding in this variable, okay? So in the example above, in this example, hedgehogs remains equal to 5, simply because, like I said, nowhere in this code, so inside this while loop, we're not doing anything to this variable. So therefore, the value of this variable is in this example is always going to be 5. So it's going to keep on running. So we would get an infinite loop, okay? So the hedgehogs remains equal to 5, which is less than 6, which makes this whole expression evaluate to true. And this way we would get an infinite loop. Now, in the instruction, it says take a look at the lucky5.java. So our file, we've set up a random generator number that allows you to simulate a roll of a die. Create a while loop that will continue to loop while die roll is not 5, okay? So while, this is the keyword that we've just learned about now. So while die roll does not equal to 5, what do we want it to do? Okay, so this is the condition, this is the expression that is going to evaluate to a Boolean value, and it says do not run your code yet. You will get an infinite loop here because the value of die roll is not changed. Obviously inside this while loop, we don't have anything that changes the value of our die roll. Okay. Now it says inside the loop reset die roll with a new random value between 1 and 6. So we're gonna do copy, okay, and inside here we have to say equal to, and if we have a look at the code, what is the code that generates a random number between 1 and 6 is this one, okay. So we're gonna copy this one. Okay, now we can run the code. Let's run the code. Okay, looks like we're not getting any errors. If we look at the instruction number 2, it says inside the while loop, above the line where you reset die roll, print out die roll to the terminal. So it would say here, do system.out.print ln. So we want to print die roll, okay, here. Okay, let's try and run this now. So we get a 3 and a 1, okay. So on this line, because of this code, we get a random number assigned to this variable, and then we say while whatever is stored in this variable does not equal to 5. So while the value that is not that is stored in this variable is not 5, then print that value and then assign a new value to our die roll. And now in this first instance, the first number that was assigned to die roll due to this line of code was 3. And it goes like this: while 3 does not equal to 5, so therefore this expression evaluates to true, yeah, it goes inside the while loop. It says print me the value of the die roll, which was 3, and then put another value in the die roll, okay. And in this case it was 1, the new value that was assigned, okay. Because it stops here, because it says is 1 now is the new value that is inside die roll. 1 is less, does not equal to 5. Yes, this whole condition is true. Therefore, print me out the number that was assigned to the die roll, okay, this variable, which was 1, and then assign a new random number to die roll. If, for example, we were to print this now after here, we would get number 5, simply because that's why the loop broke out. That's why it stopped running, because at one point, and it looks that this happened at the third attempt. At the third attempt, the randomly generated number was indeed 5, which made this whole expression evaluate to false. Therefore, it came out of the loop, okay? So 5 does not equal to 5. Well, that is false. If this expression is false, then come out of the loop, okay? Now we can move on to the next part in this chapter. Incrementing while loops. When looping through code, it's common to use a counter variable. A counter, also known as an iterator, is a variable used in conditional logic of the loop and usually incremented in value during each iteration through the code. So for example, if we have a variable called wishes and it starts at 0, okay, we have the while loop and it says while wishes is smaller than 3, then print this on the screen and then increment wishes, okay. In the above example, the counter wishes gets initialized before the loop with a value of 0, so here. Then the program will keep printing wish granted, adding 1 to wishes, so adding 1 to this variable, as long as wishes has a value of less than 3. Okay, once wishes reaches a value of 3 or more, the program will exit the loop. So the output would be would look something like this: printing wish granted 3 times on the screen. We can also decrement counters like this, so with a minus minus, okay? So we have push-ups, say we have 10 to do. So while push-ups is greater than 0, then do push-ups, and this would be defined elsewhere in this method, and then push-ups minus minus. So you will decrease the number of push-ups you have to do until you reach 0. Okay. And in the code above, the counter push-ups to do starts at 10 and increments down 1 at a time. When it hits 0, the loop exits. Now, if we have a look at the instructions, it says in coffee.java, initialize an int variable called cups of coffee with a value of 1. So we need to initialize this. We say int, the name of the variable, and the value that we assign it is 1. Okay, let's run this. Okay, instruction number 1 is done. Let's have a look at number 2. It says create a while loop that runs as long as cups of coffee is less than or equal to 100. So we have to use the while keyword, and inside here we say we want to run this as long as cups of coffee is less than, so less than or equal to 100. Okay. Okay, and it says inside the while loop we have to increment cups of coffee by 1 to prevent an infinite loop. So cups of coffee plus plus, okay? Or we could have said cups of coffee equals to cups of coffee plus 1, okay? Let's run this. And instruction number 3, it says inside the while loop above, where you incremented cups of coffee, print the following. Okay, let's print this. So inside here we say system.out.println, okay? We're gonna end it with a semicolon, and inside we have to put this line of text, and of course the value, so the digit here, is gonna come from the actual value of that is stored in our variable. We've seen this one before, so what we need to do, this is concatenation, so this is an example of concatenation. We need to add the value. So this digit here is going to come from the value of cups of coffee, the current value of cups of coffee. The 1 in this statement should correspond with the current value of cups of coffee. When cups of coffee is 100, this should be printed, of course, cups of coffee 100. Okay, so this one. Let's run this. Okay, so if we go to the very beginning, it says it starts at 2, okay, because the cups of coffee already started at 1, okay. So starts at 2 and goes 3, 4, all the way to 101, okay, because it started at 1. All right, let's go on to the next lesson. It says we're gonna have a look at the for loops now, which is another type of loops that we have available in Java. Okay. So it says incrementing with loops is actually so common in programming, that Java, like many other programming languages, includes syntax specifically to address this pattern. For loops, okay? A for loop brings together the following steps in a single line, separated by semicolon. So we initialize a counter variable, we define the looping condition, and then we increment the counter. And this is how it would look like in code. So initializing a counter variable would be something like this. So int I equals 0, okay? And then we define the condition. This would be the condition that needs to evaluate to either true or false. And then we increment the counter, which is this one here. 1 equals to 0, of course, well, in step 1, I equals to 0, it says we're initializing the variable called I with a value of 0. On in the second point, in I is smaller than 5, the loop is given a condition that relies on the value of I. And then in the third step, we have I++, which increments I at the end of each loop. Okay. So the code will run through the loop a total of 5 times. You will also hear the term iteration when it comes to loops. You iterate, it just means that you're repeating the same block of code, okay? In the instructions, it says to review the syntax for, the syntax of the for loops, and then click next when we're ready to build something. Let's click something. Using the for loops. For loops aren't just nice as syntax, they also help us remember to increment our counter, something that is easy to forget when we increment with a while loop. Leaving out that line of code would cause an infinite loop. Fortunately, equipped with the new understanding of our for loops, you can help prevent infinite loops in our code. In the instructions, it says we've provided a while loop that loops from 1 to 100, outputting a string on each iteration. Refactor or rewrite this code as a for loop. Okay. So remember, the syntax of a for loop looks like this. Okay, we've seen this one. So this is the code essentially that we wrote in the previous example. Now the same line of code, we have to transform it using a for loop. Okay, so we're gonna use the keyword for. Okay, and we're gonna say int I equals to 0. Okay, so we want to print from 1. Okay, it starts at 1 initially. We have to give it a condition. I is smaller or equal to 100. And then we say I++. And what do we want to run whenever this whole, whenever we run this for loop? Well, we want to do this, okay. But instead of cups of coffee, we have to put I here, okay, because that is the variable that we are working with. Okay, so it looks like we have a bit of an error. I forgot the semicolon at the end. Okay, and we are getting the same output here. So we have from 1 all the way to 100 here. Okay, and that is the output of our while loop. And then it starts again at... Oh, this is very random. The fact that we're like getting this here is indeed random. But anyways, we can move on to the next lesson. It says iterating over arrays and array lists. One common pattern you'll encounter as a programmer is looping through a list of data and doing something with each item. In Java, that list would be an array or an array list that the loop could be, and the loop could be a for loop. But how does this work? For loops begin with a counter variable. We use that counter to track the index of the current element as we iterate over the list of data. Because the first index of an array or an array list is 0, the counter would begin with a value of 0 and increment until the end of the list. So we can increment through an array or an array list using its indices. For example, if we wanted to add 1 to every int item in an array, called secret code, we would do this. So for example, we have the keyword for. We're initializing a counter on this line. We're checking a condition. So we're giving it the condition during which, while this condition is true, keep on running the code. And then we increment the counter, okay? And we say the secret code at index counter plus equals 1. So we would add 1 to every element, or to the value of each element in our array. So notice that our condition in this example is I smaller than secret code.length, because array indices start at 0 and the length of secret code is 1 larger than its final index. So for example, what this means, it means that, for example, if we have an array that holds 5 elements, then it means that its index is gonna go to a maximum of 4, because indexes start at 0, okay? So 0 to 4 will mean 5 elements in total. Therefore, the loop should not stop when it should stop when it's less than but not equal to the length value, okay? So less than or equal to. In the case of an array list, this code would look like this. So pretty much we have the same line of code in the header of the method here, in the header of the loop. However, because we're talking about array lists, the method that returns the size of the array list would be size, like this, rather than length, like we've seen it in arrays. So we say int num equals to secret code.get the element at index whatever, at index counter. And then we're setting, so we're using the get method and the set method we've seen in the previous lessons. Now it says in the instructions, let's use a for loop to iterate over expenses and sum up the total of all items. Start with the skeleton of a for loop. So we initialize a counter I with a value of 0. The loop should run while I is less than the size of the expenses, and then we have to increment I. So in order to do this, we use the keyword for, and we say int I equals to 0. So the expense, we start with a number of expenses as 0. So this is our counter, and then the condition is gonna be I equals to, no, I is less than, so I must be less than expenses dot size. So say you have 3 expenses, okay? This is what refers to the number of expenses, okay? So let's say we start with the number of expenses as 0, okay? But we know we have a list, okay, that has a few expenses in it. So we want to get its size, okay? And then we say I plus plus. Okay, so we can leave the body empty for now. Okay, let's run this. Okay, the next thing is to, inside the for loop, add the item's value to total. So we need to say total, which was declared here, okay, equals to total plus the expenses dot get the value of the element situated at index I. We're gonna end this with a semicolon. So what happens here is we have an array list that is called expenses, and we have these expenses, so 4 in total, okay? So this code here allows us to go through each one of them, okay, all the way to the end. This is all the way to the end, okay? And then we want to add to our total, we want to add each value, okay? So to our total, which now is 0, add 74. To our total that now is 74.46, add this value. And to whatever these two added up to, add this value, and so on and so forth. Now moving on to the next lesson, for each loops. So we're going to cover the for each loops. Sometimes we need access to elements indices, or we only want to iterate through a portion of a list. If that's the case, a regular for loop is a great choice. But sometimes we couldn't care less about the indices. We only care about the element itself. At times like these, the for each loops come into handy. So for each loops allow you to directly loop through each item in a list of items, like an array or an array list, and perform some action with each item. The syntax looks like this. So we have the keyword for, we have the name of whichever variable is stored in the array or the array list, whatever we have, okay? And then we say print out this one. So it simply prints out each element in the array or the array list. We can read the colon here as in. Okay, so for each string called whatever in our array or our array list, print out that string, okay, or print out that element. Okay, so let's have a look at the instructions. It says let's use a for each loop to find the priciest item in expenses. Build a for each loop that iterates through each expense in expenses. For now, leave the body of the loop empty. So we're going to use the notation for, okay? And we say for, let's have a look at the type of the elements that this array list is going to store. So for double expense, so this could be called anything really, expense, okay? So double E in expenses. Why expenses? Because this is the name of our array. Well, array list, okay? So expense. So for each expense in our expenses, okay? So for each of these values, and I think it says to leave the body empty for now. Yeah. Let's go on to instruction number 2. It says inside the for each loop, check if expense is greater than the most expensive. If it is, set the most expensive equal to expense, okay? Well, we can see that most expensive here has already been declared and initialized at 0, because at this point we don't know. So we're going to start at 0. So we say if. So now we're going to also make use of the if, the conditional statement that we've seen in the previous lessons. If expense is greater than the most expensive that we know currently, then set most expensive to expense. And we end it with a semicolon. Let's see if this works. So this way we get 81.37, which is indeed the correct answer, because just by looking at all the expenses, we can see that out of all of these values, the last one is the biggest one, okay, is the most expensive. Now let's move on to the next lesson. And this is the review, and it says, let's iterate over what you've just learned about in loops. So we've covered the while loops, and these are useful to repeat a code block an unknown number of times until some condition is met. So for example, if we have wishes, wishes equals to 0 at this in this example, and it says while wishes is smaller than 3, run the code, and then here it says increment wishes. Okay, we've seen for loops. These are ideal when you are incrementing or decrementing with a counter variable. So for example, here we initialize a counter, here we give it the condition, and here we increment our counter. Okay, and we tell it essentially we could use this um, as a counter to count how many times we want this code to run. Okay, so now it's not gonna be a random thing, but rather it's gonna be dependent on the value of the counter and on the condition that we give it using the counter. Okay, and then we have the for each loops. These make it simple to do something with each item in a list. So for example, we have this syntax. So the way we write a for loop is the keyword for, and then we have a look at the what we want to iterate through. So say this is an array, okay, array of strings, and we say for string, and this is just a variable, this could be any name here. Okay, for string s, let's say, in our array, then do something. Okay, let's have a look at the instructions. Feel free to play around with loops, arrays, and array lists in the code editor. So let's run this code and see what happens. Okay, this would print 28 times this this piece of text. Okay, and we could do the same thing with a while loop. Okay, so we would say while and we would declare some sort of a variable while print is less than 29, for example. Then system.out.println this text. Okay, oops. So this concludes our lesson on loops, where we have covered while loops, for loops, and for each loops.